Everybody, this is a brief video to give you an overview of the CI tooling for LabVIEW. This is the GitHub repo that is open source, readily available. It contains an example LabVIEW application along with all the tooling and infrastructure, but we are going to go straight to the dashboard, which you can get to by clicking this blue View the Live Dashboard button. What this is showing me is all the revisions to the LabVIEW source, and it's giving me some views of the various artifacts that are generated every single time we are pushing new LabVIEW code to this repo. One side note is that we are filtering non-LabVIEW submissions. So for example, we've done a lot of work on the CI infrastructure. And so if we select that button there, we're going to see a lot of other revisions that don't include changes to the LabVIEW code. So by default, we just want to zoom in on the changes to our LabVIEW source. Now, the columns here show mass compilation, static analysis via analyzer, changes to source, snapshots that are generated, unit tests, which include a number of different tools, and will be potentially inclusive of other tools like Antidoc and other things in the future. But all of this is set up and configured. I want to pull your attention first at these settings options at the top. The pipeline configuration is where we specify what tasks or activities should be run when a new revision is actually sent to the repo. So we can see those default settings. Basically, all of these things are going to be run. It is spinning up containers that are stored in the GitHub content repository. And to understand the configuration of those, I want to exit the settings dialog and draw your attention to this dependencies section. So these GitHub containers are derived from the Docker Hub containers that NI published for Linux and Windows. And then they are modified to include a variety of dependencies that are required to execute unit test framework, via analyzer, these rich snapshots, et cetera. And so we can see the core dependencies under citooling.vipc. And if your repository contains additional VIPC or Dragon files, those then will be used to modify and configure your own instance of the container. So we have three tabs here. We can see VIPM files contained within the repo. We can see NI packages that are added, and then any externalities can also be added here as well. And the idea here is that anytime those files change, if they are being monitored as selected here, then the containers can be automatically updated and restored to your GitHub content repository with that new set of dependencies preloaded and configured. And here, for example, I'm being shown that there was some change to the VIPC file, so I can opt to replace the existing containers or create new ones. And if we go back to that settings dialog, I can actually configure which container runs for a specific action. But let's go back to the dashboard and look at the outcome of having settled this up. I'm going to go to a revision that has some interesting changes. So here, for example, if I look at added new exercises, if I look at the diff, I can actually see there are 3 changes, 21 additions, and 0 deletions. I can see that mass compile on both Windows and Linux had 95% success rate, and that we successfully completed the VI analyzer. So let's click on it, and it's going to take me to this in-browser VI Navigator, which I can actually use to click through and see my code directly in the browser. You'll notice some tabs here. There are a couple different views. 1.0 is just using the static snapshots generated by LabVIEW. However, this 2.0 one, which will be the default for many of you, is a richer experience where we can actually zoom in. We can see the code. And if we have cases in a case structure, we can actually click through those. And so we can do that all directly in our browser. Note, by the way, if at any point in time you see something, you want to yell at your coworker, we have this share option, which deep links directly to what you're looking at, where you're looking at it, so you can send it to a peer and say, hey, go check this thing out. Note, this is the Linux view. We can also switch over to Windows. If we have it generated, which in this case I don't, there we go. This one does. So there's the block diagram for 2.0 generated from Windows. Here it is for Linux. Usually they should look the same, but they don't always. Here we see down here at the bottom, there are some files that actually have changes to them. So if we click the diff tag, or we could go to dashboard and look at changes, we can actually explore the diff report and see exactly what has been changed between the 2 revisions. So it's going to use that updated diff report that was introduced in LabVIEW 2025 and 2026 and give me the description of exactly what has been modified. Okay, stepping back out to the overview, we can also look at our mass compile results. Notice that we can look by Windows, by Linux. We can see exactly what was broken. We can go to the snapshot of the code. Same experience for VI Analyzer. Not a lot of interesting changes there. If we go to a more interesting one, let's go back to our dashboard and find one. This will actually give me a rich report where I can see the output of VI Analyzer displayed. Looks like all these are missing the rich output I want, which is actually a great example to then go and show you how we generate those. I can go to populate history and I can tell it to go ahead and rerun or fill in any missing action runners. So in this case, let me clear everything. I am just going to, for all 20 revisions, I'm going to rerun VI Analyzer. I can also select to keep one container warm across revisions. You don't normally want to do this because it potentially has a dirty container, but you do have this option, which is going to significantly improve the performance of execution. So if I click Q run, we'll see then on the dashboard, it has queued up. It's going to rerun VI Analyzer across the entirety. Oh, by the way, if we go back to our settings and we look at VI Analyzer, it by default will use the VI Analyzer config file that is loaded into the repository. You can add additional ones or have a per folder VI config file, but you can also put those per folder settings directly in the VI config file. All right, talking about unit tests, there are, of course, a number of different unit test tools. So here we have tabs where we can configure and use VI Analyzer, LUnit, VI Tester, and LabVIEW Unit Test Framework. I've predominantly used Unit Test Framework. It will run all of the unit tests attached in a given project. The most recent one here, we added several. So if we go look, we had several failures. Here it gives me this rich report where I can see exactly what passed, what failed, et cetera. And you can step through and see those and navigate to the code itself or down select to the type of test results you actually want to see. And this particular unit test framework doesn't run on Linux, just Windows. But if we were using LUnit or VI Tester, we would also have the ability to sort between them. Okay, one final thing I really want to emphasize is if you're looking at all this and thinking, okay, that's cool, how do I actually install it and use it in my repository? This button is critical. This button lets you specify any of your own repositories that you own, and I can point to it. I can say what capabilities I want. I recommend leaving everything default because otherwise it's going to take a lot of time customizing the containers. And then you hit this green button. It will ask you for a token, which obviously only the owner of the repo can generate. We'll save that locally. And once you've given that, it will then go through and run action runners to then create and set up the pages and all of the action runners you need and store the containers in your local repository so that you can then install this tooling and everything I just showed you into your own repository. And if we go out of here and go look at an example, which I can see a list of a bunch of clients here. So if I go to one of my own, open dashboard, the nice thing too is as we continue to iterate and improve the tooling, you can see if there's an update available. So there, for example, this particular extensible configuration dialog repo has an older version of the tooling. I can from here actually update the tooling, and that way I get all of the new capabilities. Maybe there's changes to the dashboards, improvements to how containers are installed and run, whatever. It lets all the people that may choose to adopt and use this infrastructure take advantage of new capabilities as they become available. Now, if we look at this particular repository, you'll notice that it says there are dependencies that are missing. This is warning me that, hey, when you moved it to this library, it looks like there was something here that is specific to this particular repository. If you want to make sure they're all present on the containers, it's telling me here I need to run the container update, create those new containers, store those back to my GitHub content repository, and then from that point forward, the pipeline will use that updated container. Now, because it is kind of a lengthy process, it does not do it automatically by default. You will have to opt into it. However, there is actually a setting where you can tell it require all monitor dependencies to be installed before running. One other thing to note is that there is a limit to the number of action runners you can run concurrently. I think it's 20 for a free account. By default, we set it to 5. You can change that. Of course, you can pay for more, but that's across all your repos. We didn't want to monopolize all of your capacity for one repo, so we went ahead and defaulted to 5. Anyway, this has been a whirlwind tour of the CI infrastructure that we've recently made available for LabVIEW. One final note, I will emphasize that as we've built this out, we've really focused a lot on providing detailed documentation that explains not just how the tooling works, but when it should be used, and also how we were able to instrument some of these tools and capabilities and the logic and used in deciding what gets run when, and how. So if you have any questions, feel free to reach out. Feel free to also consult this documentation. You can also track planned improvements. If we go back to the GitHub dashboard and we go to our issues, there's a lot of things that we would like to add, and also open invitations for community contributions. Many thanks to those of you who have already submitted pull requests to enhance this tool. We're really excited about the future and eager to engage. If you do have any questions, feedback, or suggestions, please reach out. Thank you very much.